good morning everyone. Assalamualaikum warahmatullahi wabarakatuh. Okay, before we start this learning process in this morning, it's quite better if we start this learning process with prayer. So, for the class leaders, the time is yours. Okay, attention please. Before we start this learn today, it's better to pray according to our religions. Pray begin. Amen. Amen. Okay, before that, I want to ask you who's absent today? Nothing? Okay. Okay, for the first time, how are you guys? Hopefully that you're in great condition so we can start this learning process, which quite good, and then stay healthy because yes, learn from the situation before it's forced us to stay at home, so it's quite good that we can stay here face to face learning. I'm so happy with that, and then I'm so happy to see you today. Okay, thank you. So we can start this learning process today. But before that, I really hope that you can give your concentration, like full concentration in this learning process, especially if, for the main learning. Today we're gonna talk about something. What is something? Okay. In our daily life, usually we always meet with many things, materials like iron, frying pan, many things. Okay, many things. Frying pan, and a leaf, and a wood, and etc. There's a lot of kind of material, and then because and also they have a different characteristic. Actually, it's actually because they have a different characteristic. What what something that what make they have their different characteristic. So here we're going to talk about chemical bondings. What something is chemical bonding? So chemical bonding was something that surrounded us with their characteristic, because materials like plastic, there's plastic, and then also iron, and also wood from the table and the chair. They have a different characteristic. They have the different solidity, and then also different materials, of course. So we can learn why they have the different characteristics through their chemical bonding. Because chemical bonding is quite a lot in everything that surrounds us. That's why it is important for you to learn about chemical bonding. Uh, there is many kind of chemical bonding, such as ionic bonding, covalent bondings, and then metallic bondings, and then covalent bonding they separate into two, like single bonds and multiple bonds. And then we're going to learn about that, because it was quite important for you to know about chemical bondings, its touch, its yes, we always touch some things with material that surround us. Okay, that was the first time. That was the first that I taught you about chemical bonding. So before we learn more about chemical bondings, it's better for us to watch the video that I share for you in the Google Classrooms tomorrow. Did you guys already watch that? Okay, it's quite good for you, but let's watch together again.
Chemical bonding. Almost everything we see or touch in our daily life is the result of a chemical bond. The air we breathe, the food we eat, the clothes we wear, and so on, are all made up of one or more chemical bonds. The world is generally not composed of isolated atoms. Rather, it is composed of molecules formed as a result of chemical bonds. The strong force that holds together the constituent particles, atoms, ions or molecules in a chemical species is known as chemical bond. The chemical bonds are broadly classified as ionic bond, and covalent bond. Let us discuss these chemical bonds in detail in this module. The bonding which results due to the complete transfer of valence electrons between atoms is called ionic bonding. It is a type of chemical bond that generates two oppositely charged ions. Ionic bonding is observed because metals have few electrons in its outermost orbital. By losing those electrons, these metals can achieve noble gas configuration and satisfy the octet rule. Similarly, nonmetals that have close to 8 electrons in its valence shell tend to readily accept electrons to achieve its noble gas configuration. In ionic bonding, more than one electron can be donated or received to satisfy the octet rule. Sodium metal has electronic configuration as 2, 8 and 1. It has one electron more than a stable noble gas structure. If it gives away that electron, it would become more stable. On the other side, chlorine has electronic configuration as 2, 8 and 7. It has one electron short of a stable noble gas structure. If it could gain an electron, it too would become more stable. Thus, the sodium atom donates its valence electron to achieve stable octet configuration. This creates a positively charged cation due to the loss of electron. The chlorine atom receives one electron to achieve its stable octet configuration. This creates a negatively charged anion due to the addition of one electron. The sodium ions and chloride ions are held together by the strong electronic attractions between the positive and negative charges. Covalent bonding. A covalent chemical bond results from the sharing of electrons between two atoms with similar electronegativities. The electronic configuration of chlorine atom is one electron short of the argon configuration. The formation of the chlorine molecule can be understood in terms of the sharing of a pair of electrons between the two chlorine atoms, each chlorine atom contributing one electron to the shared pair. In the process, both chlorine atoms attain the outer shell octet of the nearest noble gas, that is argon. The dots represent electrons. Such structures are referred to as Lewis dot structures. Thus, the chlorine atoms are joined by a single covalent bond. A single covalent bond is formed when one pair of electrons are shared between two atoms. It is depicted by a single line between the two atoms. A double bond is formed when two atoms share two pairs of electrons with each other. It is depicted by two horizontal lines between two atoms in a molecule. This type of bond is much stronger than a single bond, but less stable. This is due to its greater amount of reactivity compared to a single bond. For example, in the carbon dioxide molecule, we have two double bonds between the carbon and oxygen atoms. When three pairs of electrons are shared between two atoms in a molecule, a triple bond is formed. It is the least stable out of the three general types of covalent bonds. The two carbon atoms in the ethyne molecule are joined by a triple bond.
So, okay, according to the video, at the first meet, our first meet this day, we're going to talk about chemical bonding, especially covalent bonding. Before we start to talk about chemical bonding, especially covalent bonding, we're going to talk a basic of chemical bonding. Why atoms and elements need to pair each other. So we know that something like hydrogens and then Cl2. I give you the example for covalent bonding. You can read that from your book that this elements have covalent bonding. So why they pair each other like this? Why don't they found in nature like just Cl as monoatoms and then H just like that? Why? Because their stability. So before I talk about these things, before we talk about chemical bonding, you have learned about stability through periodic table relativity. So each group, each period, they have the different characteristics. The left one was unmetal and non-metal, and then the right one was metal. So from the configuration, also from the valence electrons like Cl, chloride ions, they have seven dots. It is according of Lewis structure. You have to read again about Lewis structure. It's quite important for you to understand. The first, to understand a Lewis structure, especially for the each element like chloride, halogen, and then all of them, because you know that the dots in Lewis structures mean the group. So if they have 7 dots, it means that they are in group 7A, right? Okay. So according to octet rules and duplet rules, so octet octet rules. And duplet rule. So, octet rule was how the materials, how atoms raise their stability, that they have 8 electrons that surround them, like group 8A, right? Like group 8A. And then, if we know that chloride have 7 electrons, and then yes, he was unstable, not stable. And then, if I have once more chloride like this, they have how many? 14, right? They have 14. So each chloride has 7 electrons as electron phalange. And then, if they want to raise the stability, so chloride must pair each other like this to form single bond. Form the single bond, right? So, okay, did you guys understand, right? Okay. And then, if we observe this bonding, 2 chlorides can pair each other like this to make their stability. Like, let's count. All of this circle, they have 8 electrons, and then also this is 8 electrons. So they goes as stable elements. That's why they need to pair each other. Something like this. But for the hydrogen, because hydrogen was in the first group, in A group, so he just have one valence electrons, and then hydrogen was the only one, the one that needs each other, so they can pair a single bond, because they just have 1 electrons, so they just can form something like this. And this is according to duplet rules, because they just have 2 to make their stability, so it's called duplet. If they need 8 electrons, they call octet. Okay, something that I'm saying before is something that repeat the video content. So I'm just want to validating that you all understand what the video is saying about. So any questions? It's still easy for you, right? So pretty good. Okay, we have talked about chemical bonding in basic, so that why elements or an atom needs to make pair each other, because we know that they need to raise their stability. So that's why they need to pair each other, because they want to be stable, something like that. And then we're going to talk about covalent bonding. What was covalent bonding, so we know about ammoniac, hydrogens, and then chlorine. Though we're talking about it before. Yes, everybody know that, right? Where's the structure of ammonia? Lower structures. So we'll give you something like this. So ammonia was 8H3. So I have 5 foliage electrons, right? Because he's in group 5. 2, 3, 4, 5. And then surrounded by H. So you follow octet rules. And then if you give attention, they have free electrons. Free electrons pledge. And then you know the ammonia solution are used to clean and then bleach and deodorize, etc. And then ammonium follow octet rules, right? So if we talk about ammonium was one of the examples from covalent bonding. So covalent bonding are formed by sharing pair of electrons between 2 atoms. They are found in long list of substances such as paper, garbage bag, sugar, bloodstreams, DNA, and every tissue in human body. Because in paper or tissue, they will come from wood, right? Okay, and then the main atom that formed them was carbon. So carbon was from group 4. So carbon that form in the ferment, the tissue or the fabric, if you burn that tissue, the color will change to be black, right? So the ash will be black. So it was carbon. Alright, okay? So carbon have pair and the bondings is covalent bonding. So then molecular substance is substance that has atoms held together by covalent bondings. So because they share each other between non-metal and non-metal materials, there was covalent bonding. But if we talk about ionic bonding, if you want to know before I talk that much, for ionic bonding, they from metal and non-metal, like Na, NCl. Na was metal, NCl was non-metal. Something like this. And then molecularly contain as many as few as 2 atoms or as many as 1,000 or even a million atoms. So for the examples like oxygen, a gas that can travel in our bloodstream process. So oxygen was the elements that have covalent bonding. And then oxygen if you want to know the Lewis structure, let's draw. If you want to know, like oxygens have how many? 6, right? 6 because it was group 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then if oxygen want to make the stability, of course it must make it has to follow octet rules, like so they need to have 8 electrons for each atom. That's why oxygen have double bonds or multiple bonds. Okay. So let's talking about covalent bonding. So covalent bonding was formed usually from non-metal and non-metal materials such as hydrogen, chlorine, iodine, and etc. And then they share the electrons each other and using the electrons together to make their stability, right? Okay. And then covalent bond they have many types. Like the first is single bond, double bonds, triple bond. As I told you before, we are talking about oxygen that they have more than one pair. They have more than one bond. So it's called multiple bonds from double bond and triple bonds. So for single covalent bond, 2 atoms share exactly one pair of electrons. For example, hydrogen, chlorine, iodine, and etc. And other diatomic molecule are molecules that contain single covalent bond. And then for double bonds, the bonds consist 2 pairs of shared electrons. For the examples, oxygen, carbon dioxide, and then water, right? And then formaldehyde, sorry, I said water before. It's a mistake, sorry. And then a molecule that contain covalent bond. And then for the next was triple bonds. Triple bonds consist the 3 pair of shared electrons. For the example, nitrogen. Yes. It was something that they have many in our atmosphere, like 75% was from the atmosphere was nitrogen. So yes, nitrogen was quite big. And then what is the structure of nitrogen? I haven't told you yet, but there's the structure. So nitrogen was from group 5. So she had 5. And then she had 5 too. So they make the stability because each atom has 5 electrons, so they form like this. 1, 2, 3, 1, 2, 3. So each atom has 8 electrons. draw using line, it's supposed to be like this, right? And then I want to see one of you, everyone, who can draw the structure of word. And then so if you can draw this one, actually you can see many of examples from your book, but I want you to draw this one and show me the structure of this one, formaldehyde and ethane. Okay, I'll be waiting. Putri here, mom. Putri, mom. Like this, right? Yes, mom. Is it correct, right? Okay, mom. Okay, I think for their task, for their assignment, was pretty good. They can write the structure of aldehyde and ethane with pretty good. So you guys can write down in your book that structure. Okay, and then you can ask your friend that already can draw the lowest structure, or you can ask me through Google Meet or through WhatsApp message. Oh, that's pretty good. Give applause. Okay, I will give you some additions, like the characteristic of covalent bonding. Okay, we have learned about the structure of covalent bond, and then we have to learn too about their characteristic and what things that make them different with ionic bonding or metallic bonding. So what is the difference? So covalent bond, when there is a strong electrostatic force of attraction between two positively charged nuclei and then shared pair of electrons, is called covalent bonding. So they share each other, like they share electron each other to make the stability. That like what I'm saying before. So the existence usually as solid, liquid, and gas. For the example, what? For solid, like wood, it changed to be paper and tissue, right? Okay, from carbon. And then liquid. Liquid, for the example, was ammonium, right? Right. And then gas. There is so many examples for gas, like hydrogen, chlorine, and etc. As we talking before. And then occurs between two nonmetals. Okay, right. And then involves they usually sharing of electrons in valence shell. And then for the conductivity, if we compare with ionic bondings or metallic bonding, they have very low conductivity. For hardeners, they're very hard to the exceptions, like they're not hard, right. Ammonia was not hard because it was liquid, and then also chlorine because it's gas, so it's not hard at all, right. For the exception was silicon, carbon, that, especially carbon that from diamond. The expensive materials like diamonds, it formed from covalent bonding, not from metallic bonding or ionic bonding. It's formed from covalent bonding. It's something that make them amazing. Was although they have something like fragile materials like gas material and liquid material, but they have a very hard materials like diamonds. It's quite something, right? It's awesome. And then they have low melting and boiling points, right? So because they gas and they're liquid, they can boil in low temperature, and then they're not malleable and not ductile. I mean, malleable is wherever you want to try to make something like curries. It was weapon, a traditional weapon of Java, and how can we make that? It's true, of course, that we need to press and then make shape of the iron, right, of the metal. But we can't make them from wood, right? We can't make them from wood. You can make shape as you want from wood, right? Okay. And then the bond energy is higher than the metallic bond. Okay. And then for the electronegativity, it was not really electronegative if we compare with metallic, with ionic, right? Because for the example like hydrogen, or for the electronegativity is not really high if we compare with natrium chloride or salt, right? Okay, that's why the electronegativity is more lower. And then for the example, okay, I taught you so many examples of covalent bonding, so hopefully that you can remember that covalent bonding was something that surrounded us, so it was quite important to learn about covalent bonding. I hopefully after you learned about this chapter, you know that everything that's around you, something that you bring like this fabric, oh, this is covalent bonding, oh, this is covalent bonding, oh, something that I heal, it's covalent bonding, it's something awesome. And then because you interactions, life interactions with the bondings, I hopefully that it will make you enjoy this capture and then enjoy for learning too. Okay. Okay. Any questions? Yes. Mom, I'm Lian. So I want to ask you, why do usually covalent bonds sometimes stronger than ionic one? You have mentioned that before, but I still can't understand what you talking about, what you mentioned that about. So hopefully, please explain more for me and for us. Thank you, Mom. Okay, pretty good question. I'm sorry, I forgot to explain for all of you about it. So, why covalent bonding have something have bonds that stronger than ionic bondings? Okay, let's remember. What does strength mean in relation to bonds? Okay, it's amount of energy need to break the bond. So it depends of energy that needs to break the bonds. And then covalent bond formed by sharing a pair electrons between two atoms. So they have like something that unstable, like chlorine ions and then chlorine ion of hydrogen ion and hydrogen ion, something like that. So they have the same characteristic and they have a sharing pair electrons share each other, okay, using electrons together, using electrons together to make bonding. And then in order to break it, we need to do one of the following. Okay, if we want to break, we need to follow this rule. Transfer one electron to one of the atom, forming the bond, and one electron to the second bond atom. This is called homolysis because the electrons are evenly separated to atoms. So the result is two radicals, and then transfer both electrons of shared electron pair to one of the atoms or more electronegative one. This is called heterolysis and form an anion and cation. So because they form from the same atoms, they can form something like a quiet strength electron. Because of what? Because of they're not really stable. They're not stable ion, right? Because they are not stable, they can form if if they together, if they join it, their electron share to be something like that. This will give you more impact, something like that. Okay. So that was our meeting today. I think that was enough. Before of that, I want to give you assignment to make a note table. So you have to make table like this. It's enough. So this is the point, and this is for covalent, ionic, and metallic. So you need to compare each bond with their characteristic according to the characteristic. I think it is something that will help you to learn about chemical bonding easily. So next week I want to see your assignment in your note. You can write that in your note. Okay? It's our deal, right? Okay. Thank you. Okay, before I close this meeting today, our meeting today, I want to learn one of you that can give us a statement or the conclusion from what we learned today. Anybody want to try? I give you a try. Okay, good. Lian. Okay, Mom. I will try. So, according to our meeting today, I will conclude that we have learned about ionic bonding, especially covalent bonding. Covalent bonding was bonds that form by when the outer electrons of two atoms are shared. So they share the electrons each other to make the stability. Usually they form from non-metal and non-metals atoms like hydrogen, nitrogen, chlorine, and etc. And then, but they have a stronger bonds if we compare that with ionic bonds. Okay, because we need uh, quite big energy if we want to take break of covalent bondings. And that's all. And why this is important for us, because covalent bonding and chemical bonding in basic was surrounded us, so this is really important for us. Thank you, mom. Okay, I think that's all that I can give for you. Hopefully that you can learn as well from this meeting this day. uh, I'm so thankful for you that you give me attention and then you enjoy this learning process. Hopefully that you can understand well and that you enjoy this learning process, because this is something that really important for you. That's all. I apologize for my mistakes that I do this day. So thank you for the attention. Wassalamualaikum warahmatullahi wabarakatuh.